Hey everybody, Mr. Bowman here. In this video, we're looking at the 3.9 bivariate data topic, and specifically, we're looking how to interpret that regression line. That's part of the achieved criteria that we need to know how to do. So in the internal, if I was doing this, step number one that I'll be doing is I would be stating or writing down my equation. So write down equation, and I'll show you where that is. It's on our graph. So this red stuff that comes up, that is the regression line information, and it's that very top one, the longest one, that is the equation that we're looking for. So in this case, we can find the weight of a kiwi. So the weight of a kiwi is equal to the number there, we've got 0.061319. That little star is the same as a time, so I'm going to put a times there. So times by the kiwi's height, and then we are adding the other number, 0.11618. So that's the first step I always do, just jotting down the equation. So step number two, we are now going to think about interpreting kind of what that means. And the key part we're looking to interpret here is that first number, and we call this the gradient. So number two is all about interpreting the gradient. And the gradient's a really, really useful bit of information, because if we're down the bottom of our diagram, so what the gradient tells us is if the bottom axis increases just by 1, then we're going to expect the other axes to change by whatever number the gradient is. So in this case, if it goes across by 1 unit, we're expecting the kiwi height to increase by that 0.06139 number. So we need to write that and explain what that means. So what I always do, and everyone's wording is slightly different, so the gradient of 0.061319 means that as the height of the kiwi increases by 1 centimeter, or it increases by 1 centimeter. And I just want to note, when you're talking about this one, it is always increasing by 1 centimeter, or one, whatever that bottom axis is talking about. So it's always increasing by 1 there. A lot of people change that up to 10 and then get the number wrong, but the gradient is always about an increase of 1. So that doesn't change no matter what. So what we've got, the gradient of 0.61319 means that as the height of the kiwi increases by 1 centimeter, we would expect and then now we're going to look at the other variable, and in this case it's going to be weight. The weight of the kiwi to increase by that number that we've got, so 0.061319, and in our case, because that relates to weight, we've got the kilogram unit at the end there. So that's the first example that I want to run you through. And I guess this one's important because our graph, we've got a positive graph, right? Because it is increasing over time. The wording is going to be really similar if it is decreasing, which will be the next scenario. However, there will be a slight difference. So let's move on over to the second diagram that I've got going. Here it is. So this time around, we're comparing stride length with marathon times. And I guess a really important part that I want to highlight is this graph is a negative graph. It's going downwards. So that ever so slightly changes what we're trying to do. So even though it's a little bit different, we're not going to change too much of what we're doing. So step number one, we're still going to write down the equation. So write down equation. And then once we've written down the equation, we're going to do the same next step. We're going to interpret the gradient. And it's this second part that will have slightly different wording. So I'll put a bit of a star there just to highlight that. So step number one, we'll find the equation. And as always, it's up the top by all the red stuff that they've got there. So in this case here, our equation, minutes, so that's how long the person will complete the marathon in, will be equal to, and it's very difficult to see, but there's a little negative sign there where I've circled in green. So it's going to be negative 1.8696 times, again, that little star means a times, stride length. And then it's going to be plussing that number at the end, which is 503 or 530.33. And I just want to highlight that negative gradient there. That represents the declining nature of our graph. So that negative number is why the graph goes down every time, because when you add a negative number, the number gets smaller every time. So now what we're going to do, we're going to interpret that gradient that we've got there. And it's going to be the exact same that we did there, except we're going to be using the word decreasing instead of the word increasing. And that's because it's a negative going downwards. So let's start talking about it. So the gradient of negative 1.8696 means that as, and then don't forget, we're looking at the bottom variable increasing by 1 unit, and in this case 1 centimeter, so it's always that bottom one increasing by 1. So as the stride length I'll add in a bit more context of the marathon runner increases by 1 centimeter. And then just a reminder, the first one always increasing by 1 centimeter. We would expect the time taken, or the minutes. So let's do time taken because that's better language. Time taken in minutes to decrease. And this is how it's different to the previous question. The other one was increasing. We're saying this one is decreasing because it is by, and we're going to write down our number, except we're going to ignore the negative sign of it because the negative sign of it is considered when we use the word decrease earlier. So it's going to decrease by 1.89 or 1.8696 minutes. And that wraps up the interpretation of this particular line. So when we go back between the two, I just want to highlight this one here, we're using the word decreasing because it's going down. And if we looked at our previous example, we're using the word increase because it is going up. Hopefully you found this a useful summary of how to interpret the gradient, and hopefully I gave you some good tips to remember for when your real internal happens. So thanks so much for watching. Now let's get into some mahi.